In this video, I will talk about transition voltage in a clipper circuit. I will show you how to determine the transition voltage in case of two different clipper circuits. While solving the clipper circuits, I started my circuit analysis by finding the transition voltage for that specific clipper circuit. Finding the transition voltage in a clipper circuit makes the analysis of that circuit lot more easier. So, what is the transition voltage? The transition voltage is that value of applied input voltage for which the current in the clipper circuit becomes zero. Transition voltage is that value of applied input voltage Vi for which the current in that circuit will be equal to zero. What does that mean? See, at the input side of any clipper circuit, we apply an alternating signal. That alternating voltage Vi changes its magnitude with respect to time, or this will be a time varying quantity. So we will get a specific value of input voltage Vi. For which the total current in the circuit I will be equal to 0, and that specific value of input voltage is the transition voltage. Okay, we can also say that the transition voltage separates the conducting and non-conducting regions of the circuit for the given input voltage. So what does that mean? That means we have a value of input voltage Vi that divides the input voltage into two different regions. One will indicate the conducting state, another region will indicate the non-conducting state of the circuit. In one region, the diode will be in forward bias, so we will get current conduction in that region. In another region, the diode will be in reverse bias. Therefore, there will be no current conduction in that region. Now, I will show you how to identify the transition voltage for two different clipper circuits. Consider this clipper circuit. This is a positive clipper circuit. Now see, in this clipper circuit, we do not have any bias voltage. We are applying a sinusoidal input voltage which is varying between plus 20 to minus 20 volt. Now see, if I consider the positive half cycle of the applied voltage, during positive half cycle, the positive terminal of the applied voltage will be connected with the P side of D1 and negative terminal will get connected with the N side of D1. That means during positive half cycle, the diode D1 should be in forward bias, and we know that when a diode is in forward bias, if I consider the ideal case, the diode can be replaced by a short circuit. So if I replace this diode with a short circuit, you will see during positive half cycle I will get current conduction in that region. That means when Vi will be greater than 0, or Vi will go through positive half cycle, that will be the conduction state for the circuit. In this region, Vi will be greater than 0 volt, and we will get conducting state in the circuit. Now see, if I consider the negative half cycle, this terminal will be negative and this terminal will be positive. The positive terminal will get connected with the N side of D1 and the negative terminal will get connected with the P side of D1. That means during negative half cycle, the diode D1 should be in a reverse bias, and during negative half cycle we can replace the diode with an open circuit. If I replace this diode with an open circuit, you will see in this region the input is going through negative half cycle. That means Vi will be less than 0 volt. In that case, diode is in reverse bias, so I can replace it with an open circuit. If I replace the diode D1 with an open circuit, you will see when Vi will be less than 0 volt, that will be the non-conducting state for the circuit. Now see, we identified the conducting and non-conducting regions. Now what will be that specific value of input voltage which we denote, which we call transition voltage, for which the current in the circuit will become equal to 0. See, in the circuit, if Vi becomes equal to 0 volt, that means if I talk about this horizontal line, this is the Vi is equal to 0 volt. If Vi becomes 0, you will see in the circuit the current I will be equal to 0. As for Vi is equal to 0 volt, the current I becomes 0 in the circuit. That Vi equal to 0 volt will be the transition voltage for this positive clipper circuit. So this horizontal axis will indicate the transition voltage, or this Vi is equal to 0 volt will be the transition voltage. Now look at this circuit. This is a biased clipper circuit. In this clipper circuit, we have the bias voltage V1 of 5 volt, and we have the applied voltage Vi, which is varying between plus 20 to minus 20 volt sinusoidally. Now see, how do we identify the transition voltage in case of this kind of circuit? When we have more than one energy sources in a circuit, we can use the concept of superposition to analyze the behavior for each of the source in the circuit. If I use the superposition theorem here, you will see I will keep Vi active at first. In that case, I should replace the bias voltage V1 with a short circuit. If I replace the bias voltage V1 with a short circuit, I will get a circuit like this, because we are considering the effect of input voltage Vi only. So during positive half cycle, this terminal will be positive and this terminal will be negative. The positive terminal of the applied voltage will be connected with the P side of diode D1 and N side will be connected with the negative terminal of input voltage. Now see, I can say that during positive half cycle, input voltage Vi is trying to put diode D1 in forward bias. That means during positive half cycle, input voltage is trying to conduct the current in this direction or in forward direction. Now consider the negative half cycle. During negative half cycle, this terminal will be negative and this terminal will be positive. So this positive terminal will be connected with the N side of the diode D1 and a negative terminal will get connected with the P side of diode D1. That means during negative half cycle, the input voltage Vi is trying to put the diode D1 in reverse bias. We know that when a diode is in reverse bias, the diode behaves like an open circuit, and during the reverse bias there is a very small amount of current flow which is known as leakage current. So during negative half cycle, input voltage is trying to conduct the current in this direction, and this current will be the leakage current. Now consider the case when V1 is active. When we will keep V1 is active, we will mentally replace this input voltage with a short circuit. In that case, you will see the positive terminal of V1 will be connected with the N side of D1, and the negative terminal will get connected with the P side of D1. That means V1 is trying to put the diode D1 in reverse bias, and we know that when the diode will be in reverse bias, there will not be any current flow except the leakage current. So V1 will try to conduct the current in this direction by keeping the diode in reverse bias. So here we have total three effects: this forward bias effect, this reverse bias effect due to V1, and this reverse bias effect due to the negative half cycle of the input voltage. So what will be the transition voltage? From the definition of transition voltage, we know that transition voltage will separate the conducting and non-conducting state of the circuit, and at that instant the current in the circuit should be equal to 0. Now let's say if our input voltage is gradually increasing and input voltage Vi is exactly equal to the 5 volt, as this is a positive voltage, this terminal will be positive and this terminal will be negative, and between these two terminals our instantaneous voltage Vi will be 5 volt. So as this is the positive terminal and this is the negative terminal, input voltage will try to conduct the current in this direction when Vi will be equal to 5 volt. Let's say I am denoting that current with II. See, we have this bias voltage of 5 volt, that this is its positive terminal and this is its negative terminal. If I consider the current in the circuit due to this bias voltage I1, that current should flow from this positive terminal towards this negative terminal, or that current should flow in counterclockwise direction, and that current is I1, as the potential difference between this terminal to this terminal is equal to 5 volt, and the potential difference between these two terminals is equal to 5 volt but in opposite direction. So when Vi will be exactly equal to 5 volt, the current in clockwise direction and the current in counterclockwise direction will be equal, as they will minimize each other. The total current I in the circuit, which will be the difference of input voltage II and I1, that current will be equal to 0. So this Vi is equal to 5 volt will be the transition voltage. For this circuit. Now which region will be the conducting state and which region will be the non-conducting state for the circuit? This is our transition voltage of 5 volt. Now see, if our input voltage Vi becomes greater than 5 volt, that means if I talk about this region of applied voltage, in this region you will see input voltage will try to conduct the current in this direction due to the forward bias of D1, and this bias voltage will try to minimize that current by conducting the current in this direction due to the reverse bias. You will see as the value of input voltage Vi will be greater than the value of V1, the effect in the forward direction will be greater than the effect in the reverse direction, or this effect will be greater than the effect in this direction. So input will put the diode D1 in forward bias and our circuit will enter in conduction or conducting region or conducting state. Now consider this case when input voltage Vi will be less than V1 or Vi is less than 5 volt. That means I am talking about this portion of input voltage. If I consider any voltage between this region, you will see the effect in reverse direction will obviously greater than the effect in forward direction. So our diode will be in off state or in reverse bias. Or if I consider the negative half cycle, during the entire negative half cycle, the input voltage will try to keep the diode D1 in reverse bias in addition to the effect of this bias voltage V1. So in this entire half cycle, our diode D1 will be in reverse bias, and we know that when a diode is in reverse bias, it behaves like an open circuit. So when Vi will be greater than, so when Vi will be less than 5 volt, this region will be the non-conducting state, and the transition voltage separated these two regions of conducting and non-conducting states. Okay, that's it. Thank you.